Hi everyone, I'd like to start by showing you the apparatus that we're going to be using for the rest of the lab here. You might recognize the track from the lenses lab, the last lab, and in fact you might even recognize my daughter's room. But we're going to be putting some totally different things on. Let me start by showing you this is the red laser. Let me turn it on here. And you'll notice that it shoots across to the backboard here, the same backboard as last time as well. And what we're going to be putting that beam of light through is this slit wheel. It's a multiple slit wheel and it's got lots of different orientations. We're going to start with this orientation where we're going to be comparing a single slit and a double slit. And then we're going to cycle through to a bunch of these other options, including multiple slits, different double slit patterns, and so on and so forth. So I can stick this right here, and it'll intercept that beam with whatever slit we choose in this wheel. And you'll notice that down here, we are already starting to get a pattern, which I'm going to go dark in a second and we can look at that. But let me show you one last thing. I'm sticking this slit, I'll be putting it at the 0 centimeter mark. And then all the way down here, we're going to be sticking this back plate at the 110 centimeter mark. There you go. Alright, let's go dark and check out this pattern here. This is our single slit, double slit comparison slide. And I wanted to show you a zoomed in version so you could really notice the details. On the left side we have our single slit pattern, and on the right side we have our double slit pattern. What I want you to notice about the single slit pattern is continuous lines broken up by dark spots. And these continuous lines represent the constructive interference, where the two beams of light are constructively adding to each other and creating bright spots. And then there's these dark spots here, where two beams of light are hitting this backboard and creating nothing. I think that that's really impressive, that you can add two beams of light together and get a completely nothing dark dead spot. And then it's a repeating pattern of single lines. But on the other side, you'll notice that we have that same repeating pattern of bright blobby area, dark spot, bright blobby area, dark spot. That is our single slit pattern. But on top of that, you will also notice our double slit pattern. Double slit pattern is a combination of the single slit pattern and the smaller double slit pattern on top of it. Now if I was counting M's, I would start with the middle, and I would go outwards 1, 2, 3, 4, 5, and I'd even count the dark spots where those double patterns should exist. And then I could use the equation to figure things out. This is a comparison slide between two different double slit patterns. On the left side, you see two slits that are close together, and on the right side, you see two slits that are further apart. Now, all of these have the same slit width, they're just separated by a different distance d. And if you think about this, the distance between the slits d, as that gets bigger, the y has to get smaller. But notice one important thing here. The single slit pattern, these big dark spots here and here, are shared between both of these slit patterns. And that's because the slit width of each of these slits is going to be exactly the same. So the single slit pattern will stay intact, but the double slit pattern will change based on the separation of those two slits.